So data structure is an arrangement of data in computer memory. So data structure is a particular way of storing and organizing the data in computers so that it can be used effectively, right? So we write code, we write program in computers, right? So this, whatever we write the code, the data, whatever we feed in the memory, how we optimize, how we use that data, this is how we store the data in memory. The data structure is not only used for organizing the data, it is also used for processing, retrieving, and storing the data. So data structures are mainly classified into two broad categories. So let's say primitive data structures and non-primitive data structures. So primitive data structure, you might have heard of integer, boolean, characters, float. These all data types you have heard of. These data types are actually primitive data structures. And non-primitive data structures are those which are different from primitive and which are created from primitive data structures and can be created by your own. Right. Let's look into primitive data structures. Primitive data structures is a fundamental type of data structure that stores the data of only one type. So let's take an example of integer. So if you see here, integer variable can hold integer type of value, right? So integer can you introduce as int I equals to 5. So you can only introduce integer I to 5 value. Primitive data structures contain fundamental data types. So data types as in integer, float, character, pointer. These fundamental data types can hold us only a single value, right? So primitive data structures will contain some value, that is, it can't be null. So the point we need to take care here is, like, there should be one value associated with one of the data type or data structure in primitive data structures, and it can't be null, right? So if we don't, in different programming languages, if let's take an example C. So if we don't declare the data structure, the data type, so we introduced int I, and if we don't declare it as equals to 0, it will take a garbage value, right? But in Java, so it's defined in Java compiler that if you don't introduce it, it will give it a 0 value or a predefined value. So it depends on compiler to compiler or programming language to programming language as well, right? So let's take an example. Let's take an example of take a look at non-primitive data structures. So non-primitive data structures are those data structures which are created using primitive data structures, right? So you might have heard of linked list, and all these, right? So these are primitive data structures. So non-primitive data structures. So non-primitive data structures is a kind of data structure that can hold multiple values, either in a continuous or random location. So continuous, as in if you're taking example of array list or linked list or arrays, normal arrays. So they are continuous, which are stored in memory in a continuous fashion, right? So if you introduce int I bracket new I equals 5, that means you're introducing 5 chunk of integer data type as in continuous, which is present in the memory in a continuous fashion, right? And or random location means it could be anywhere in the memory. So which is an example of linked list, right? So example of non-primitive data structure are arrays, linked list, stacks, queues, heaps, etc., etc., right? Non-primitive data structures can consist of null values. Now these data structure can be null. So you may introduce like list integer list, it could be null as well, right? Non-primitive data structures are classified into two parts now. These are linear data structures or non-linear data structures. So linear data structure means it could be continuous, it will be in an array form, or it will be the next node will be after the previous node, and if you traverse it, it will give you one after another node which has been stored one after another. But non-linear could be in any fashion. So basically the example of non-linear could be trees or heap of that sort, right? So so if you see here, the non-primitive data structures are linear and non-linear, and linear can be of two types: static and dynamic. Static as array. What do you mean by static? That it can't be changed once you have like initialized it. You can't change the value of that initialized array, right? And dynamic as in linked list, array list, stack, queues. These are the example of dynamic non-primitive data structure, which is linear, right? So if you come to non-linear as in the examples are trees, graphs, or it could be heap, priority queue. All these are non-linear data structures, primitive data structures, right? So what are linear? So again, let's take a look at linear data structures. The linear data structure in which data elements are arranged sequentially or linearly, where each element is attached to its previous or the next adjacent elements, and that is called linear data structure. Example of linear data structure is stack array. So basically, if you store an array of 1 2 3 4, so 2 is after 1 and before 3, right? And if you traverse it, it will be printed as 1 2 3 4 only, right? So again, let's take a look at static data structure and dynamic. Static, as I told you, the size won't be changed, you can't change the size, and it will be using a fixed memory. So static data structure has a fixed memory size. It is easier to access the element in a static data structure. An example of this data structure is an array, right? And dynamic data structure, the size is not fixed. So if you want to introduce elements and you don't know the size, how many elements you need to introduce in that data structure, so you can use a dynamic data structure in that. And so the compiler or the code inside, like if you use array list, so they are designed in such a way that they also don't uh, excess the need, increase the time complexity or the time to introduce the to use the extra element or to introduce the extra element, right? The size is not fixed. It can be randomly updated during the runtime, which may be considered efficiently conserving the space, that is space complexity of the code. We'll look into the time and space complexity later in algorithms. So let's park it here. Let's park these things here for now, right? So example of data structures are queues and stacks, right? In nonlinear data structures, where the data elements are not placed sequentially or linearly, are called nonlinear data structure. Nonlinear data structures, we can't traverse all the elements in a single run only. Example of nonlinear data structures are again trees and graphs, right? So we use data structure to perform different operations, right? We need to, so as I told you earlier, so in this so data structure not only used for organizing the data, it is also used for processing and retrieving the data, right? So these are the operations which can help you retrieving the data or processing the data. So the data structures is processed using certain operations. Some commonly used operation performed on the data structures are adding new data items into a data structure, right? If you want to insert an element into a data structure, you can add this data. So we have different data structures, as I told you, right? So we have array list, hash maps, sets, all these. So all these data structures has different time complexity. So basically, time complexity is nothing but the time taken for an element to add an element, for a data structure to add an element or insert an element, right? So how much time it takes to insert an element. So array takes different time to add an element. Again, it depends where you want to insert the element. So if you want to insert an element in the middle of an array, it will take of n time, because you have to move the other elements to one side after the element you have introduced, right? So introducing an element in an array, at the back it will take O of one time constant, but in the middle it will take some time, order of n time, right? Same is goes for deleting. So different data structures take different time for deleting. If you want to delete an element from the end of an array, it will take O of constant time, which is, it doesn't take much time. But again, if you want to delete the first element in the array, you have to move all the elements to the left, right? So as to like keep the array in a proper state, right? Sorry. So, and the other operation is searching. Searching is as it says, find specific data item. Traversing is accessing each element of the data exactly once for processing. So right. So what you want to like extract the data, access the data exactly once. So in an array, you can do a normal for loop, right? So for int I equals to 0, I smaller than n, I plus plus, and you can print that array in one reversal, right? Sorting, arrangement of data items and data structures into a specific order, right? So you can sort sort the elements in increasing order or decreasing order in any other fashion, right? And merging, as it says, combining two list of data items into single data list. So if you have two data structures, so there should be an operation that can help you merging these two data structures, right? Creation. So each data structure needs to be created as well in the first place, right? 1 2 3 4 5 is an array, so you need to create that array. So you need to initialize that array first, and you need to put all those elements in the array. So putting all these elements to the array is the actually the creation operation. So operation through which the data structure is created is called creation operation. One second. All right. So some examples of data structure. So let's take an example of stacks here, right? So stacks is nothing but the collection with access only to the last element inserted. So we call it FILO, first in last out, right? So if you have put, so let's say you're putting 1 2 3 4 5 in this order. So 1 will be in the bottom, then 2 3 4 5, 5 will be at the top. So the element that you put that you has put the last will be removed first, and the element you have put in first place, it will be removed last, right? So insertion in the stack is like how it's done is push on the top of the stack. So pushing element on the top of that stack. So basically it's similar to stacks, like you have stack of boxes, right? So if you want to remove an element from the stack, you will be removing the top element, right? So this is how you insert and remove, delete the element. Delete is the pop from the top of the stack. And if you also want to insert the stack, you will be inserting at the top of the stack, right? Get retrieves the top element of the stack. So basically you are not allowed to get any of the element in beneath the stack. So if you call a get operation, it will retrieves the top element of the stack, which is 5 in our case. Right. So the other example is queues. So queues is like collection with access only to the last element inserted. So not the last element, it's wrong. So the first element inserted, right? FIFO, the first in, first out. So whatever you inserted the first place will be removed first. So 1 2 3 4 5, you have inserted 1 in the first place, 1 will be removed before any other element. So there is NQ and DQ. Push on top of the queue. So pushing the element on top of the queue is NQ. So putting elements at the back. So 1 2 3 4 5, if you want to insert 6, so 1 2 3 4 5, 6 will be inserted after 5, right? But when you want to dequeue, like taking out of the element, you will be popping the element from the end of the queue, which is if you dequeue an element, it will remove the first element, which is 1 in our case, right? And if you want to retrieve the last element, we want to retrieve an element, it will give you 1. So 1, which is at the last of the queue, right? So let's take an example or another example of tree. So tree, as we learned, it's non-linear data structure, right? Non-linear data structure, that means it's not linear. Yes, you can see like 1 is not, 2 is not after 1. You can see that in here, but 3 is not after 2. So it's attached to 1. So the tree is a collection of elements called nodes. One of the node is distinguished as root node. So one is root node here, along with the relation of parenthood that places a hierarchy structure of the node. So basically we have in trees, we have relationship as a parenthood relationship. So each node is a parent node to its child node. So basically for 1, 2 and 3 are children's. So so tree can be of two types as well. Like it can be a binary tree, so which has only two children's, right? One left child or right child. But there could be n array tree as well, where the parent node can have n number of children. So it's not necessarily like each node have only one child or two children, right? So it can have n number of children. So let's right now let's focus on the binary tree. Binary tree is where we have left child and the right child, right? Now, left child and right child. So one has left child as 2, one has right child as 3, right? Now we have another name which we call as leaf, right? Leaf is where the node which doesn't has any child in any child. So 3 doesn't has any child, so we call 3 as a leaf node, right? 6 is also a leaf node, 4 is also a leaf node, 7 is also a leaf node, 8 is also a leaf node, right? So these are the leaf nodes that we have. So these are the data structures that we have, right? So we can go ahead with algorithms now, right? So basically what are algorithms? So algorithm is a finite step-by-step list of well-defined instructions for solving a particular problem, right? So if you want to solve a problem, so if you're writing a code, right? So if you're going through a code, so you are have a problem introduced in your like exam or something like that, right? So you will write some code to solve a particular problem. So if you are said like find the sum of two numbers, right? Find the sum of two numbers. You are given two numbers, you need to find and return the sum of these two numbers. So you can write a function called sum, taking two elements as parameters, as number one and number two, and you need to return the sum of these two numbers. So you can return like you can introduce an integer and sum equals to a plus b, and you can return return sum, right? This is the basic and the simplest algorithm that you can write, right? It is used, so basically let's go ahead. It is used to manipulate the data contained in the data structure, as in searching or sorting. So what does it says? So manipulating the data. So basically if you have an array, so what you want to do is you want to write a algorithm to merge two lists, right? To merge two lists. So we have two lists, list A and list B, right? List A has a few numbers and list B has few numbers, and you want to merge them in some order. So let's take an example how you want to merge these two numbers. So given first array is also sorted and the second array is also sorted, right? Now these arrays are sorted, you want to merge these sorted arrays. So you will be jumping around with these numbers, you will be retrieving these elements, and you will be putting these elements as if which one is smaller, and you will be putting the small element in the new array in your new data structure, right? So you will be manipulating the data structure. It states explicitly, one second. uh, am I on mute?
No, Sagar.
Okay. All right. Yeah. So a program has, so okay, it states explicitly how the data will be manipulated. So, right. So look, in the program, you will specify like how you will be manipulating the data. So in the sorting case, if you're sorting an array, you will be manipulating how you're, so you will write instructions of sorting, how you'll be sorting the array. So how you'll be manipulating the array given data structure so as to sort the data structure that you have, the data in the data structure that you have. A program has input data and is expected to produce output data, right? So as I said you, as I told you, like if you're given, if you want to find an write an algorithm to return the sum of two elements a and b. So you are given the input data which is a and b, and you need to return expected produce output data is a plus b, right? So you'll be returning a plus b, right? Each instruction can be carried out in a finite amount of time. So each instruction, so basically it shouldn't be infinite time, right? It can't be an infinite loop or infinite thing that it's running all the time. So it need to be a finite code or finite amount of, it should take a finite amount of time. All right, let's move ahead, which is how to find the effectiveness of the algorithm. So we know algorithms is like writing code, using data structures. So one second. Yeah, so you're writing you're writing some algorithm, so some code using some data structures. So example, let's say you are you're sorting, so you're doing a traversal to an array, right? So what you want to do is you are given an array 1 2 3 4 5, and but you just need to simply output 1 2 3 4 5 as in sequence, right? Or otherwise you can take an other example of find the maximum in an array, right? So maximum array is you are given an array, you need to find the maximum element, which is 1 2 3 or 5. 5 is the maximum element, right? So you need to return return that. So what you can do is you can write a for loop here, right? And you can take a maximum element, you can in each operation in the for loop you can compare each element with the maximum element. If the new element which you are iterating or which you are traversing is greater than the maximum element that you have taken, which you have searched before, so if it's greater than that, you can replace the max element with that. Or we'll also write a code for this. Or let's take an example there. Let me share the another screen. Sorry, share this tab instead. Yeah. So let's say we have integer array list is equals to new list, new array as one. So let's take it as 1 comma 2 comma 3 comma 4 comma 5, and we need to return the maximum of so let's change 1 as 5, 1 as 7. We need to return the maximum of these. So what we can do is we can take a max integer, and we can put it as some very negative value. Let's take it as -1000. So for now we can take it as -1000. Also, if it's given like it's an integer only, positive integers only, and we don't have 0, we can take 0 here as well, right? So maximum is 0 for now. For int I equals 0, I smaller than the size of the array, which is list dot length I plus plus, right? If list I is greater than max, what we need to do is either in max is equals to and if, so we can return or cout system. Right. So this is a simple code where you are printing maximum of the element. So what I did here, I have taken a list which has 7, 2, 10, 4, and 5. The max integer max as introduced as the maximum, which is actually the output element. We can also call it as resultant result, right? Which is storing the result. 1 second. Yeah. So this is storing the result. So we are taking a loop for I equals to 0, I smaller than the length. If the element, ith element, is greater than max. So in the first iteration, it will check 7. If 7 is greater than 0, it will say yes, 7 is greater than 0. So max will become 7 then, right? In the then it will go up I plus plus. It will check if I is smaller than the length. It will go down. It will say 2. Is 2 greater than max? Max has become 7 now, right? Let's write it here. Max has become 7 now. Now 7 is 2 is not greater than 7. We'll not do anything here. We'll go up 10. 10 is greater than 7. That's correct. So the max will become 10 now. We'll go up for 4. 4 is not greater than 10. 5 is not greater than 10. And we'll be printing 10 here, right? So So what I was saying is, you're writing this. How would you know what is the efficiency of this code? What is the, how can I calculate? How will I know how much time or space this code is taking? So efficiency is calculated in the terms as time complexity and space complexity, right? Time complexity of an algorithm quantifies the amount of time taken for an algorithm to run as a function of length of the input, right? Length of the input as in n, the size of the array, which is n, right? And the space complexity is the problem solving using the computer requires the memory to hold the temporary data or the final result while the problem is in execution. So you're given an input array of size n. So we are not considering that size. We are more interested in the temporary data that we are storing in the function or in the program that will nullify later. The amount of memory required for by the algorithm to solve the given problem is called the space complexity of the problem, right? So we represent both the time complexity and the space complexity in big O of O notation, right? So let's calculate the time complexity of this algorithm, right? So we are given the list. So we are so let's take an let's calculate for each operation how much time we are taking, right? So we are initializing max. This will take a constant time, right? Then we are actually going through a loop, a whole for loop, right? Whole for loop, as in we are traversing the whole array, right? So if the size of the array is n, so we are actually performing this loop n times, right? We are going one after another and n time. So this whole loop will take O of big O of n time, right? Big O of n time, as in like we are iterating to the whole array of size n. So we are actually, the time complexity is an order of n only for this for loop. Printing the array again takes constant time. Sorry. Now, so what will be the time complexity of whole this program? That will be constant big O of n and constant, which is actually big O of n only, right? And also, if you look here, so we are initializing an array, right? We are taking a list and putting elements in this list. So putting element and initializing the list also takes order of n time. So as in whole, if you look here, so n complexity will be order of n for initialization plus some constant, which is, we write it as order of 1, plus for loop again n, then for printing it again, which is constant of 1. Now let's come here back to this here slide. So the order of complexity is exponential is very bigger than any of the polynomial time complexities, right? So the exponential has time complexity greater than any of the polynomial, then n cube, or before n cube there is n to the power 4, n to the power 5, so like that, n to the power 4, n to the power 2, right? And there, then you can put also here as root n, order of root n, right? And after that, order of n log n, order of n. So these are the ones which you like see a lot in your coding when you practice algorithms, data structure algorithms. These are the on notation, the space complex time or space complexity that you will take a look a lot. Order of n, order of constant order. So as you see here, order of n is greater than constant, right? Order n is greater than constant. That is, you can nullify the order constant one. So in this code, you can actually nullify, you can cancel the order one here, and two order twos will become 2 into the order 2. Again, the 2 is again a constant. So you can simply say this whole program takes order of n time. Right. So this is in time complexity of this. Let's look into the space complexity. So storing the data in the list takes order of n space complexity. So space complexity is order of n for storing data, right? Plus, now you're also storing data as an in list, right? And then you are also storing max element, which is a constant space, which is of one, which is a constant space, max for max, right? And then here, if you see, there is an integer as well, right? Integer I, which has a scope till the for loop only. So it introduces, so it is there, so big of one, but it only has scope till this for loop. After that, it will get erased again. Plus, there's nothing after that. There, we are not storing anything apart from these, right? So again, here also, if you see, we can nullify or we can remove the order ones, because order ones are smaller than order n, and in final, you can say order of n is the space complexity for this program, right? So these are the this is how you will calculate the effectiveness of the program. So I was telling about this sorting algorithm, insertion sort. So insertion sort is similar to the way you sort the playing cards in your hand, right? So you're playing cards, you have 10 cards in your hand, and you will be sorting those cards. Now the array is virtually split into sorted and an unsorted part. So from left to somewhat in between, so there will be some cards which will be sorted in the sorted order, while you will be traversing through the array, and the other part will be unsorted part, right? So values from the unsorted part are picked and placed to the correct position in the sorted part, right? So in the sorted unsorted part, you will be picking up some element and you will be putting in the sorted order, right? Let's go through a pseudocode for this. So insertion sort, so you'll be having a procedure is insertion sort. So you'll have the n is the length of the array. So you'll be starting from I equals to 1 to n minus 1. N minus 1 is the last element, right? So first element till the last element. So you'll be going through the first element of this, which is 3, and so you will be assuming that 4 is assorted. So 4 is a sorted part, and we are assuming that others are unsorted. So we'll be putting elements from unsorted part to a sorted, right? So j equals to j equals to I. So we'll be doing j equals to I. So j is another variable that we are using, which is the second iterator, right? While j equals is greater than 0, and I j minus 1 is greater than a j minus 1 is greater than aj, right? So you'll be iterating from I, and you will be checking if j minus 1 array of j minus 1 is greater than the array of array j, right? So you will be swapping those elements till that happens, right? So j equals to j minus 1, you will be decrementing j, and you will be ending all the for loop, while loop, and everything. So let's take an example of here. Let's take example here. So 4, 3, 2, 10, 12, 1, 5, 6, right? So we are iterating from I equals to 1, which is 3. So we are assuming that 4 is already a sorted part, and 3 to 10, 12, 1, 5, 6 is unsorted part. So for I equals to 1, you will come here. So j is also 1. So j is also 1 here. So j is greater than 0, still j is greater than 0. A of array of j minus 1, so which is 4. 4 is 4 greater than array of j, which is 1. So is 4 is greater than 3? Yes. So you will be swapping these elements. So you'll swap this. So this will become 3, 4, 2, 10, 12, and so on. So what you have done here is, in the first step, you have actually sorted 4 and 3 as well. So now the new array will become 3, 4, 2, 10, 12, and so on, right? Now this j will decrement, it goes up. Now the value of j will become 0. So you'll say like j is greater than 0, which is false. So this while loop will end this for loop. Now in for loop, I will become 2. So you will have the second element. You will be taking the second element. So j is also 2. J array of j minus 1 is compared with j. So array of j minus 1 is, you will be comparing this to this, right? So you will be comparing 2 to 4. So is 4 greater than 2? This is yes. So you'll be swapping 2 and 4 now. So 4 will become, 2 will replace 4 and 4 will replace 2. So the array will become 3, 2, 4, 10 and so on. Now the j will decrement. It will go up again in the while loop, starting from the while loop. You will check j is greater than 0, which is true. Now j has become 1. So you'll be checking array of 0 is greater than array of 1. Now, since array of 1 is 2, since you have swapped it in the previous iteration, so you will be comparing 3 to 2, right? So it will become 2. So now 3 is greater than 2. So you will be swapping 2 and 3 again. So it will become 2, 3, 4, 10, and so on. So you'll be repeating these in the same order, similar order till the end, and you will be actually sorting one after another. For each iteration, for each I, you will be iterating all the elements. So all the green elements will be iterating and will be getting sorted in the orders. So this is how actually the insertion sort works, right? So let's take a look at the time complexity of this algorithm, right? So what will be the time complexity? So the time complexity is actually the worst case time complexity. Worst case, in the worst case worst case in the worst case, how much a program can take, how much a program can take the time to complete, right? So in that order, so we'll start with n equals to the length. So we'll be introducing n, so it will take a constant time, right? Now for loop, the for loop is going from 1 to n. So this will be going for n times, right? And we go down, there is a while loop as well. So while loop is also going from j equals to I, and it will go and it is decrementing till j becomes greater than 0, right? So if j was 5, so in each iteration in the while loop, j will become 4, 3, 2, and 1, and with 0 it will end the while loop, right? So for each I, j, the iteration of, for each I, the iteration with j is actually I, right? I minus 1. So is 1 less, because it's going from I to 0, 1 basically 0th. So it will be I minus 1, or you can also say I, right? So for each I, for each element, the iteration inside is going ith times, right? So for for the first iteration, it will be 1. So for the second iteration, the jth will go twice. For the third iteration, it will go three times. For the fourth iteration, it will go 4 times. For the fifth iteration, it will go 5 times, right? So if you are taking a look, so it is actually a progression 1, 2, 3, 4, 5 till the n, right? And you already know the sum of first n elements is n into n minus 1 by 2, which is actually nothing but order of n squared. So this algorithm is order of n squared time complexity, right? So this is n squared time complexity. So the insertion sort is actually taking time complexity as n squared. Now, what about the space complexity? So here, as we have mentioned, that we don't consider the input array as in the space complexity calculation, right? So we won't be taking the consideration of array, the list of array which is already there, which is already given. So we'll be considering all the elements in the procedure itself, inside the procedure. Now n is actually a constant, right? N is in a constant space. I is also constant space. J is also a constant space. Other than that, actually, we are not using any of the other space. We are just manipulating the same array, right? So algorithm is, so in the definition, we also have said like algorithm is nothing but how we are manipulating the data structure. So we are actually manipulating the data structure, the given array itself, to sort it out, right? So I is constant, J is constant, N is constant. The space complexity for whole this program is a constant, right? So yeah, so this is actually the algorithm, the basic introduction of data structures and algorithm. So what we can do now is like we can like quickly revise all these what we have learned now, and then we will jump into some of the questions, and we'll see like how we can use a perfect data structure to actually reduce the time complexity or space complexity for a given program. right? So we let's revise from the beginning. What are data structure? Data structure is nothing but the arrangement of data in the computer memory. The data structure is not only for organizing the data, but is also used for processing and retrieving and storing the data, right? Classification, primitive data structure, non-primitive data structures. Primitive data structure we already know: integers, floats, characters, and all those, right? Boolean and all that. Non-primitive data structures are but nothing but which are created using primitive data structures. So those are non-primitive data structures. So for example, array list, linked list, tree, graphs, all those are non-primitive data structures. So this is how you're organizing the data using primitive data structures, right? So now non-primitive also are categorized as in two parts: linear data structure and non-linear data structure. Linear data structure, as we learned, are one after another. So 1, 2, 3, 4. 2 is coming after 1, and 3 is coming after 2, or yeah, 3 is coming after 2, right? So they are in order. But what about in non-linear? Non-linear data structure is when this are in random fashion. They are not after one another, right? So this is that. Linear data structure has still in two parts of two types: static data structure and dynamic. Static is an array that you can't change. The size of the data structure that you can't change is the static data structure. Dynamic is which is not dependent on the size. Like you don't need to specify the size in while initializing the data structure. You can increase the size as you want. Whenever you want to include or add an element to the data structure, you can add it. It is dynamic in nature, right? Now, non-linear data structure, non-sequential, right? Not placed sequentially is the non-linear data structure. Come again, like going like ahead, we have the operation of data structures. So we also said like each operation for each data structure are different. So right, the time complexity for each data structure is different. So the searching in array takes order of n time. Now we know order time complexity, right? So searching in an array, you need to iterate through the whole array, right? And you need to find if this element is equal to the target element that we are searching, right? So you need to iterate through whole array to find if this element is present or not. Wherein there are other data structures as well, like hash maps or hash tables or something like that, those, or tree map, tree sets in Java. I'm taking example in Java, right? These data structure takes lesser time to search than in array. So hash map or hash sets take order of one time, which is constant time in searching, because they use hashing in their implementation, right? So the implementation of hash maps and tree maps are way out of beyond of this session, but we can introduce that later. So hash maps and tree maps takes log of n times. Tree map is actually implemented through binary tree itself, self-balancing binary tree. So tree map takes order of log n time. So insertion, as we discussed, insertion operation takes of n time if we want to insert in between the array, or if you are inserting at the back, it takes O of one time. Same as goes for deleting. Deleting the element from the array from the back takes order of one. Otherwise, it takes n. Searching, as we already discussed, traversal in an array in any of the data sets actually takes order of n time, because you want to traverse through all the elements exactly once for processing. Sorting depends on data structure to data structure, right? Now the tree map is actually made in such a way that if you traverse it, it gives you a sorted array itself. Sorted array. So if you have put 5, 3, 1, 2 something in tree map, so if you traverse through this tree map, it will give you the elements in the sorted order, which will be 1, 2, 3, okay, or anything like that, right? So merging, these are the operation, and creation of the data structure itself takes some time complexity, or space complexity is always in, so the time complexity as well. So that is the creation time. Now come to the we looked at some of the data structures which are stacks, which is like philo, first in last out. Insertion, we took into insertion, deletion, and get on that. We queues, FIFO, first in first out, DQ, NQ, get, tree, which is binary tree, which is a non-linear data structure. Then algorithms, like the algorithms are nothing but the step-by-step list of well-defined instructions. Now, the algorithms are also, like we have seen, took a look in sorting algorithm. We manipulated the data. We manipulated the data structure array list, right? By using some algorithm in the sorted algorithm, right? Insertion sort. So this was the definition of algorithms. How we effectively find the effectiveness of the algorithm is time complexity and space complexity. The order of complexity is very important, which is exponential, polynomial, n log n, and order of one, which is constant, right? We represent the time complexity and space complexity in big of O notation. So we took a look at insertion sort, pseudocode of that. Yeah, this is what the session, and let's move to some problems, right? Let's do it together. Like we'll use this ID and code it together. So the first problem that we'll look into is we are given an array. We are given an array. So we need to find if this array has two elements whose sum is equal to a target, right? So for example, let's take example of this array itself. So what will be given? So let's create a function here. Public static find some target, right? So you will be given, and you will need to specify the return type as well, which is boolean, right? So you will be given an array, which is, let's say, a list, integer list, right? So you're given a list here. Sorry, or you can take an array as well. So let's keep it as a list here. So you're given a list which is similar in the 7 to 10, 4 and 5, and you're also given a target int target, right? So you're given a list and a target. You need to find if sum of two numbers is equivalent to a target or not. So we are searching for, let's say we are searching for 11. So 7 plus 4 is actually 11, right? So we'll return true in this case. But if we are looking for some target as 20, so do we have two elements whose sum is 20? No, right? So we'll be returning false in that case. So we'll first take a look at the naive solution, which is a basic solution, what that can be seen, like written by any of the programmers. So we'll use nested for loop here. So what we'll do is, like, for for int I equals 0, I smaller than, let's take n, list dot size, n is nothing but size of the size of the list, n plus plus. So what we'll be doing here is, for each I, so we'll be iterating I till the end. So for each I, we'll be looking for a j such that I plus that j is equal to the target. So we'll be using nested loop. For each I, we'll be looking for a j. We'll be traversing from I plus 1 till the end, and we'll look for that j such that I plus j equals to the target, right? So we'll write for int j equals I plus 1, right? J is smaller than n, j plus plus, right? And we'll see here if list of I plus list of j. Okay, so this is a list, not an array, right? So we need to write it as get I and j. So to make it simple, let's take it as list only, array only. Sorry, target and array, right? Array and target. So list j, right? This is equals to target. If this is equal to target, we just need to return true, right? Because we have found a pair whose sum is equal to target, right? Otherwise, if this whole nested loop and whole thing goes and we haven't returned true yet, we can return false. Yeah, right. Now we can also put a check on the given given elements, right? Given elements as in, if what if list is equals to null. As I've told you, non-primitive data structures can be uh, put as null, right? So if the list is null, so list.size will throw you an error, which is null pointer exception. So what we can do is we can check in the first place that if the list is null or not. If that is the case, we can simply remove return, or you can also throw an error, or we can return false there, then and there. Or for simplicity, we can also check like if the list dot size is smaller than 2, right? Then also if this list of size is smaller than, and we don't have two elements, how we can return those, how we can check like two elements sum is equal to target or not, right? So we can return false in that case. So this is the problem. So this was the solution. So let's take a look at like what is the time complexity for this function, right? So list is already given, so the array is already given, the target is already given, right? So we are not considering these time spaces, right? Now we'll look at time complexity first. So this will take a constant time because we are just doing a check, right? This is constant time. Let's put here like big of 1. Let's move ahead. What about this? Int n equals to the size. This is also one constant, right? We're introducing n, but we are taking a constant time, constant space. We are not taking any longer than n, or in order of n space, right? For loop. In for loop, what we are doing is this also take order of 1 time. In the for loop, what we are doing is we are for each I 2 7 2 10 4 and 10 4 and 5, for each of these i's we're looking for j's which are for those j's which are greater than I, right? For 7 we'll be looking for 2 10 4 and 5. For 7 we are looking for other 4 elements. For 2 we are looking for 3 elements. For 10 we are looking for 2 elements. For 2 we are looking for 1 element. So as we learned in the insertion sort, like it's similar to a progression, right? 4 3 2 1, and in that case that complexity has becomes order of n squared, right? So this will become this whole nested for loop will become order of n squared, right? Now you'll be returning. So returning anything will take again order of 1, which is constant order time, right? So if we look into the whole algorithm, whole solution, we'll see like we see like it is taking order of n squared time. So the time complexity for this program is order of n squared, right? So let's take a look at space complexity now. Right. So for space complexity, I already told you, like we'll not be considering list, the array, and the target because they are already given, right? So we'll be looking at this. So we are not taking any space here. We are taking order of 1 constant space for n, order of 1 space, right? In this for loop, we are only taking order of 1 here and order of 1 here for I and j, and then we are returning. So as in whole program, we are just taking order of 1, which is constant space, right? So this whole program takes time complexity as n squared. The time complexity of whole program is n squared, and the space complexity is constant. right? So how we can improve this? So this is a very famous question by interviewers. They ask like, how can you improve this? I know the solution is too naive and straightforward that you're using n squared, or you're using nested loops, and you're checking all the elements, all the pairs, and you're giving n squared time complexity. Can we improve this time complexity? So let's take another approach, like how we can improve this time complexity, right? So as I've told you, that data structures are actually very useful in creating effective algorithms, right? So here we actually can make use of hash set to check if this element is present in the table or not. So what we are actually even doing this in this algorithm itself. So for each element I, for 7, we're actually searching for some element with which 7 plus that element becomes target. So we are actually looking for target minus 7, which is 11 minus 7, which is 4. We're looking for that 4, if that exists in this array or not, in the remaining part. Or what we can do is what we can say is, for 4, like as in j as 4, we are looking for I which is before 4, right? Which we are looking for that I which comes before 4, with which target minus 4 equals with which the 4 plus that element, ith element, becomes target. Or we are looking for target minus 4, which is 7, which comes before 4, right? So let's write that let's go through that program, and let's see what will be the time complexity and space complexity in that case. So static boolean, let's copy it as a whole. Right? If list is equals to null, or list dot size. It's really beneficial to check this edge case. So we can call this as edge case as well, right? So interviewers are actually very curious to see if you are putting and taking care of edge cases or not. So this is actually a very important edge case in an interview, where you're actually checking if the list is already null or not, right? So next here is if int n equals to list dot size. Here it won't be size now because we have changed it to an array. It will be a length, right? Or int I equals 0, I smaller than n, I plus plus. So we are doing a for loop for each I. For each j, we can say, like as I told you in the second, each j we are checking, right? For each j we are checking, and we are actually using hash map here, right? So hash map, so hash set, sorry, hash set integer set equals to new hash set, right? Now what we'll be doing is we'll be checking if the hash set has that element that we are looking for, that ith element that we are looking for, right? So what we'll do is if set dot contains target minus the list jth element, if that contains this, then we can return true at the same time, right? Or otherwise, if it doesn't, right, and we haven't returned true, what we have to do is we have to actually feed the set as well, right? We have to put that element to the set. So we'll be putting list j. Right now we'll be returning at the end. If we haven't returned true anytime in the for loop, we can return false. Yeah. So what we have done here, is we have introduced hash set. So we have in the first loop, like first iteration j, when j is 0, right? You will be doing is you will be checking if the target minus the list element is there in set or not. But initially set is already empty, so it won't be. right? So you will be putting set dot add, you will be putting that element to the set, which is 7, right? Let's take example of this. So this is the input. So list is this, right? And let's call set equals to initially it's empty, right? So initially the set is empty and j equals to 0. For j equals to 0, when j is 0, you are here. If set contains, you are put, it doesn't contains because set is empty, you will be adding that element to the set, which is, but you're adding 7 to the set, right? You're adding 7 here. Now j has incremented in here, and if j is smaller than n, which is true, you will be checking again if target minus 2, which is 11. Let's say target is 11. Target here, target equals to 11. So target minus 2, which is 9. So 9 is 9 there, is 9 there in the set or not? No, right? So it, what it will do is, it will do nothing. It will add 2 in the set. One thing that we need to take care here is, so the set won't have 7 or 2 in this order. Set can have 7 or 2 in any order, right? So but if we traverse through this set, so it won't be returning 7 or 2 in this order. It could be anything, and we don't know about that, right? And in the third iteration, when j will become 2, you will be checking for 10. So target, which is 11 minus 10 is 1. Is 1 is there in set or not? Which isn't. So you will add 10 here. So what's the use of using set here? So we'll discuss this after checking whole, like going through whole this for loop. I'll tell you what is the use of using set here, right? So you will go above. I'll become 0, 1, 2, 3. You are here for 4. 4. You will be checking 11 minus 4 is 7, and now you will say yes, set contains 7, right? Set contains 7. You return true here, right? Now you have returned true. So now the question was, so why are we using set here, right? What's the use of using set? What's the benefit of using set here? So basically, set actually is a data structure which gives you the advantage in searching. So searching in set actually is order of 1 time complexity, right? So whatever the size of the set is, so let's say there are n elements. So if you're searching for any element in that set, of n elements, it will take order of 1 time, which is constant time, right? So this is the use of different data. Now, if you have like used a different data structure whose searching time is constant. In case of array, the searching time was order of n, right? We are actually iterating through the whole array to find that element is present or not, right? But in case of set, we are just feeding the set and we are just checking if that element is present or not in the set or not, right? So this is actually the use of data, use of data structure, using a proper data structure, and that helps you to minimize the time complexity. So let's take a look at time complexity of this program now, right? So the time complexity for this has become, let's remove this, time complexity will become, so let's take a look from here. So we are just checking, this is order of 1. We are introducing an element which is order of 1 again. We are actually initializing a set, right? We are initializing set, but we haven't like given any size here. We are just initializing it. So initializing a set also doesn't take much of time, right? It's also constant. Now we come here for the for loop for each j. So for each j is going from 0 to n. So this will be order of n, right? So we will be iterating through all the elements. So while we are iterating through all the elements, we're doing this. So what we are doing is, we are just checking in the set if that elements, if target minus list j exists in the set or not. And as I told you, that searching in a set is order of 1. So this is actually order of 1. Adding element in the set is also order of 1. For each j, the operation is order of 1. So for this whole loop, right? There are n elements. For those all n elements, the time complexity for all those n elements is 1. So the total time complexity is for this for loop is order of n. So this is now, which was earlier order of n squared. Now it has become order of n, right? And the returning element or returning some as anything will also takes order of 1 time, right? So this whole will take order of n. Let's take, so like the catch here is space complexity. Not to reduce the time complexity from n squared to order of n, we are actually using set. We are actually using a data structure to store it. So we are not considering list or target as in space complexity as we didn't in previous case, but we are actually using a set to show all the elements, right? So if we haven't got any element, so set would have n elements in it, right? So here, if we look at here, if we are not using any space here, we are using a constant space. Set, we are using set, and for set we are storing n elements. So the space complexity for storing n elements in the set is order of n, right? And j is constant, and other than that, we are not using any space. So the space complexity has become n, right? So to decrease, to reduce the time complexity for n squared to n, where we have to use some space, or which is of order of n. So there is a trade-off now, right? Should we use some space in the memory to reduce the time complexity? Is it beneficial, or is it worthwhile using some space to reduce the time complexity, right? So this is actually another important question, which are asked in the interviews, that you have actually reduced the time complexity from n squared to n, but you have also used some space now. So what is the best algorithm in these two cases? So let's compare these two algorithms now. Now the n squared algorithm, if we take a closer look at this, right? So we assume for a computation, if any program like takes 1 second for iterating through 10 to the power 8 elements, right? 10 to the power 8 or 10 to the power 9 elements, it takes 1 second. So for iterating 10 to the power, so for iterating 10 to the power 9 elements, let's take an example, 9 elements, it takes around 1 second, right? So what if n is equals to this, it takes 1 second. So n squared in this program where the time complexity was order of n, it's taking 1 second time. But what about n squared? N squared will become 10 to the power 18, which is nothing but 10 to the power 9 into 10 to the power 9, which is actually is nothing but 10 to the power 9 seconds. Now, how much is 10 to the power 9 seconds? 10 to the power 9 seconds is like way too much, which is equal to, we can say 1, 2, 3, 4, 5, 6, 7, 8, 9 seconds, right? If you divide it by 60 to make it as minutes, so it will be, if you cancel 1 0 here, it will be this much minutes. If you divide by, again, if you divide by 24 for to again divide by 60 to get in hour, so this will be now 36, this much of hours, or divide into 24, this much of, so you got the idea, right? It's too much to get processed. So again, if you tell this to the interviewer that n squared is too high than an order of n time complexity, and this is beneficial to have to use n space if the elements are of order too high, right? So yeah, so this is how you will reduce the time complexity by using some space in the to create an algorithm. Yeah. So we are actually done about time. So I'll tell you why interviews in any of the MNCs or any of the product based companies interviews, they usually ask for data structures and algorithms. So why they ask data structure algorithm is because, so the request they are handling, the request and the scale they are working on, the startups or any of the MNCs like Google or anything like that, right? So the scale is tremendous. So their scale are actually high, and they're looking for those candidates who can deal with those scale and who can write a code efficiently and can think outside the box to find that algorithm which can reduce the time complexity or space complexity or the complexity of the program itself, right? So they are looking for this that's why they are asking data structures algorithm. And while you code it, right, so they also look for if you're using proper function name, like variable names or not, right? If you're properly naming, if you're properly writing, so how much your code is like readable or not, how much easy to read it is it, right? So this also they take care of. So that's why while evaluating you through a data structure algorithm problem, they evaluate your problem solving skills, right? How you write code, if it's like a readable code or non-readable code, how you actually solve the problem, right? And if you were able to solve it in the best time complexity or in the best efficient manner or not. So that's why they get a lot of information by asking you only one uh, problem itself, right? That's why they ask for data structures and algorithm in their interviews. So we actually have like 15 minutes left. So if you have any questions from the GUI team or from me, you can ask. Hello? No one is saying anything. Am I audible? Can anyone please confirm?
Yes, Sagar, you are audible.
Yeah.
I got a question. Which college course is best related CS after 12th? From Sudan.
Which college?
Which college course is best related to computer science after 12th standard?
All right. So after 12th standard, if you're going through college courses, right? So college courses, I have gone through MIT Open Courseware, which is MIT as in US MIT, right? So there they have uploaded videos, lectures, live lectures. So you can take a look at those. So they are actually very beneficial in computer science fundamentals. Or you can go through other courses as well in like Guvi itself or Coursera and other platforms. But I would suggest you go for the MIT OpenCourseWare, or NPTEL is also nice. NPTEL is from IIT's professors itself. So NPTEL courses are also nice. Any other question?
Yes. One participant is asking like how to prepare for Google Step Scholarship. Google Step Scholarship.
Google Step Scholarship. Actually, I'm not completely aware. Is it an internship program?
Yes, it's an internship program.
Right? Yeah. So for the internship program, they actually ask for data structure algorithm only. So any of the interviews related to Google are based on data structures and algorithms. So I myself have given like 7 rounds of data structures and algorithms while getting in Google. So yeah. So in any of the programs, so anyway, like for step interns, the complexity of the problems or the problems they will ask is will be easier than the interviews after college or if you have experience. So for internships, they will be easier.
Okay, okay. I got another question. So
Yeah.
this person is asking which data structure is used for dictionary and spell checker.
Dictionary. So basically for dictionary, they're using, so dictionary is sorted, right? So dictionary as in Python language, you're asking?
Uh, no, like the real dictionary, I guess.
Okay, so for real dictionary, it's sorted, right? It's sorted in order, sorted in the elements that have the strings, sorted in string order. So they actually use sorted array, or they also can use tree map in that case,
Okay,
right? So
okay,
in that case, for if you want to search something, right? So let's take an example of dictionary in like dictionary is in sorted order, right? So we can take in some numbers. So 1, 2, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 numbers, right? You're looking for some 7. So what you can do is divide the array into 2, because it's sorted. It will be easier for you to find 7. You can say, so divide the array into 2, you will be at 5. You can simply say the 7 will be after 5, right? So you have, for each step, in each step you'll be dividing the array in two parts. The algorithm will become log of n, right? So you'll be like quickly, you will be able to quickly find the element or the number or the string that you want to find in the dictionary.
okay. I've got another question. So this person is asking like, what is the difference between linear and non-linear data structures? And is there like anything that you prefer personally while working?
So basically linear data, so each data structure has their own use case. So we have taken a look at hash map. So hash map is actually a non-linear. So right, as I told you, 1, 2, 3, 4. So 2 is coming after 1 and after 3 is coming after 2. That only happens in array or in any of the linear data structures. But in hash map or hash set or tree map or tree set, these data structures actually uses no, these data structures actually are non-linear data structures. So right, so each data structure has their own use case, right? So stack has their own use case. Stack problems are used a lot in real-time application as well. So undo operation that you're used to do in Windows or any of in the browser, you'll or in text editor, you do undos and redos. They actually use stack, right? So stack has also, but that is linear, right? But the non-linear are hash map and hash. We already taken a look. Hash map is useful. So each data structure has their own use case.